Good afternoon, my name is Ankur. Today we will learn thermodynamics through some questions. First of all, what is a system? I want to know, students, what is a system? System is assembly of particles which you took for consideration, which you took for investigation, and that can be described through thermodynamic variables. For example, if I consider a water bottle which have water in it, so if you consider this as a system, it can be described, the water inside can be described by its temperature, by its volume, by its pressure. So through thermodynamic variables we can describe a system. Okay? So here is a question, a cyclic process. So first of all, what is the state? Suppose you took a system, it is at state A, means it has some fixed value of pressure, temperature and volume. Okay? Then suppose you heat that, so its volume increases. It means suppose you heated it up, its volume increases to it attain another state B, through this process. Okay? So let us again go through the question. This is a cyclic process and it is shown on VT graph, volume temperature graph. The same process can be shown in PV graph. How it can be shown? Which of these are the options? Which of them are correct? Which of them are correct? Okay, so we will solve this. So this is a graph A to B. We can see that this A to B, if we extend this, it passes through origin. Means if a graph is a straight line passing through origin, that means x is directly proportional to y, or y is directly proportional to x. Okay, so here AB process is a process in which B is directly proportional to T. And in thermodynamics, mainly we are considering gases. We are considering system as gases. So V is directly proportional to temperature in process A to B. This A to B process is, I should write it separately. This A to B process is V is directly proportional to T. When it is possible, if you write ideal gas equation, P is equal to nRT. What is N here? Number of moles. If you write V is equal to nRP and T. So V, it is saying that V is directly proportional to T. That means this should be constant. If this is constant, that means number of moles in a system, in a confined system is constant. Then R, universal gas constant, whose value is 8.31 joule per kg Kelvin. It is fixed. Then pressure. So only pressure should also be fixed or constant. So pressure is constant. This implies this is a constant pressure process. So AB is a constant pressure process. AB should be constant pressure. AB should be constant pressure. So here AB is not a constant pressure. So we can reject these two graphs. We can reject these two graphs. And we are left on with only two graphs. So we have to judge now based on that. And you can also see that BC is a constant volume process. Even though state is changing, its volume is constant throughout. Its volume, so suppose volume is 40 meter cube, is constant throughout. So किसी का volume constant है B से C, the volume is constant. See volume here. B से C volume should be constant. और इधर भी B से C volume is constant. अभी टाई हो गया. So finally we should see C to A process. In C to A, the temperature is constant. If temperature is constant, that means if T is constant, that means if you write T is equal to nRT gas equation, if T is constant, number of molecules are constant, number of moles is constant, if a gas constant is constant, then that means P is equal to constant. The whole term is become constant now. That means P is equal to constant. This implies P is inversely proportional to B, और इसको ऐसा बोल सकते हैं rectangular hyperbola. जिसका ग्राफ ऐसा है. The graph is like this. अब देख सकते हैं जैसे V बड़ा तो P छोटा हो जाएगा. जैसे V बहुत बड़ा तो ये छोटा हो जाएगा, धीरे धीरे छोटा हो जाएगा. और V कम करो, V अगर 0 को टेंड करेगा तो जैसे 0 को टेंड करेगा तो ये इंफिनिटी हो जाएगा, ये इंफिनिटी हो जाएगा. You to get this on a contrary, ये ऐसा नहीं होगा. ये V बढ़ रहा है तो P भी बढ़ रहा है, बल्कि इनवर्स रिलेशन. और इसको एक पर्टिकुलर टर्म बोलते हैं, which is rectangular hyperbola. So your B is your answer. So we will move to the next question. It is a similar question. Here PT graph is given. Which graph shows the same process? Which graph shows the same process of this? Again, look at this. This AB is P is directly proportional to T. Again, if P is directly proportional to T, that means V is constant. How we get to this? Through ideal gas equation. If P is directly proportional to T, that means V is a constant. V is a constant. Okay. So first, that AB process is a constant volume process. So AB is a constant volume process. So direction, which I guess the direction should be like this. So AB is a constant. We can reject this. Constant volume. AB is a constant volume. Either take here or AB. So this also can be rejected. Okay. So AB is a constant volume process, whereas BC is a constant pressure. BC is a constant pressure. Final one is CA. CA is a constant temperature. Constant temperature we saw. For constant temperature, T is inversely proportional to V. We get a rectangular hyperbola whose graph should be like this. So CA should be like this in PV graph. So this is your answer. Okay. Next question. Shall we move? Okay. Okay. Work done by gas. Suppose you have considered a system, a piston. first you have taken distance into the arrangement in which gas, you have written gas, and this gas is your system. This gas is your system. This is your system. This gas is your system. Now you have given this gas some heat, and it has displaced by some value or a small value, a small displacement dx. It has moved now here. The piston has come here. So the piston has come from here to here. Okay, and the gas has pressure P inside it, and this variable. You try to understand. As we can't say about this. It will be variable. It will be constant. Suppose this gas, suppose you have an injection, not injection, but it's a balloon. If it is larger in size, if it is larger in size, it has some P pressure. If you compress that balloon, the pressure will increase since it occupies the same number of molecules in smaller volume. Same number of molecules in smaller volume. तो उसमें ज़्यादा pressure होगा. It bursts with higher intensity. If you see, so we can't say about pressure. As it moves, the pressure will vary. Pressure increase हो सकता है. Depends on many factors. Internal energy कैसे change हो रहा है, work कहाँ मिल रहा है, या adiabatic process है, मतलब process पे भी depend करता है. Okay, we'll see that. But ये pressure लगा है. Okay, so what is force? Force is pressure into area. Suppose the area of this piston, the cross-sectional area of this piston is A. And you know what is work? A mechanical work or in physics we do work. What is that work? Is force into displacement. Dot product. Or here it is Fdx. Okay, pressure 0 degree. Okay, angle between force and displacement is 0 degree. So what is our force? Is the pressure into area dx. This is I must say this is small work. It can do even larger work, but a small work. For small work we write dw. So this is your dw, and this dw is equal to P. A into dx. A into dx is this small volume. This small volume. We can say d. Small volume d. So small work done by piston, done by gas on the piston is this much. If we want to get the complete work, we have to integrate. We will get complete work, which is P from V1 to V. You know this integration? By integrating, we add the result. We add the quantity. Small volume, but if it does large work, complete work, then we take integration. Okay? So, okay, let us discuss something more on it. So you must have studied area under the curve. Area under the curve क्या होता है? For example, yx. अगर हम y dx लिखें, this means area under this curve. Area under this curve. Similarly, if you take PdV, means PdV is the work, and suppose from stage 1, means P graph PV, indicator diagram. अच्छा indicator diagram मतलब P में relation होता है, okay? So this is an indicator diagram which changes its state from 1 to 2 through this process. So area under integration of PdV gives area under P graph. Area under curve in PV diagram. So this area is your work. So this can be written in note also, that the work done is the area under PV graph. Okay. Next. So there are many processes. Through which we can change the state of a system. For example, isobaric. Bar, it is written bar here. Bar is a unit of pressure. Bar is a unit of pressure. So this means isobaric means pressure is constant here. Pressure is constant in this process. Isochoric. Isochoric means your volume is constant. Volume is constant here. And isothermal, thermal, T is equal to constant, means your temperature is constant here. Isothermal means pressure is constant. If pressure is constant, if you see P graph, suppose a piston gas works and change state from 1 to 2, but it has to do with constant pressure. So it is constant pressure. So area under this graph is work done. Area under this graph is work. So work done in isobaric process is, as we know, V1 से V2 PdV. But since P is constant here, so P can be brought outside. This implies P V2 minus V1. If you know the integration, yeah. Okay, so work done by isobaric process is P1 V1, or we can write P1 V2 minus P2 V2, or this is work. This is your work. In case of isochoric process, the graph would be something like this: constant pressure, then constant volume. 1 से 2 जाएगा, for example. 1 से 2 जाएगा. So you are not moving anything. You are not increasing your volume. Means you are not doing any work. Your piston is still. Your piston do not move. That means, जैसे स्टीम इंजन कैसे फंक्शन करता है? इसको आप हीट देते हैं किसी भी प्रोसेस के लिए आपने, ठीक है? आपने इसको हीट किया इस गैस में, और ये पिस्टन को मूव कर रहा है, तो दैट हीट एनर्जी इज कन्वर्टेड इनटू मैकेनिकल एनर्जी. हीट एनर्जी इज कन्वर्टेड इनटू मैकेनिकल एनर्जी. तो इसी को वर्क कहें. यही वर्क किया, हीट एनर्जी दिया, एंड यू गेट वर्क, यू गेट सम वर्क. But here you don't get any work. You see, the piston do not move. Your volume is constant. That means work in isochoric process is zero. Isothermal process. PV is equal to nRT. This is ideal equation. We can write T is equal to nRT by V. Can you write this? Definitely right. You can write. Okay. And we have also seen that isothermal process would be rectangular hyperbola. So we know that work is equal to integration V1 से V2 dV. Your P can be replaced with this N, R, and T is also constant, so it can be brought outside. If you know the integration of this dx by x का integration क्या होता है? Integration of 1 upon x is ln x. So here integration, you will get final result as this is your work done in case of isothermal process. Work done in case of isothermal process. So work done in case of isothermal process is nRT ln V2 upon V1. This nRT can be written as P1 V1 ln V2 upon V2, and it can also be written as, since nRT is constant, means P2 V2 ln V2 upon V1. Can you write this? Yes. Suppose because P1 V1 is equal to nRT and P2 V2 is also constant. So nRT can be written as P1 V1 and P2 V2, and also P1 V1 is equal to P2 V2. This implies V2 upon V1 is equal to P1 upon P2. So it can also be written as n forms nRT ln P1 upon V2. So all are important, students. Next, what is the cycle process? Okay, before the cycle process, let us do a question. Suppose this is a system whose volume is increased. It has pressure P, V, and T. Finally, you get a volume of 2V. You get a volume of 2V. एक प्रोसेस था, you attain this by two different processes. एक बार आपने क्या किया? Through isothermal process. एक बार आपने isothermal process से किया. At other time you did it through isobaric process. तो इसमें W1 वर्क मिला हमें और इसमें W2 वर्क मिला. मुझे W1 और W2 का रेशियो वर्क. Suppose n number of molecules are there and still finally also n number of molecules. In case of isothermal process, nRT ln final volume upon initial volume. So I am directly writing 2. In case of isobaric process, we know that P V2 minus V1. And doing this, final volume is twice of initial volume. So we get V. Initial V and P. nRT can be written as P. P1 V1 is initial volume, initial pressure. If we divide them, W1 upon W2, we get ln 2.